Okay, let's talk about pumps. We've all heard that they suck water, right? I mean, it seems so obvious, but it's also completely wrong. Today, we're going to bust that myth and show you the invisible force that actually gets the job done. So let's just get right to it. Do pumps create some kind of pulling force to lift water? The answer is a huge, resounding no. They don't pull. They can't pull. The real magic is something else entirely. The myth is that the pump is like a person pulling a rope, doing all the heavy lifting itself. But the reality is actually way cooler. A pump's only job on the inlet side is to get out of the way, to create a low pressure zone. It's the incredible weight of our atmosphere that does the real work, literally pushing the water for us. The best way to think about it? It's exactly like drinking from a straw. You're not actually sucking the soda up. All you're doing is lowering the pressure inside the straw, and the higher atmospheric pressure outside does the rest, pushing that drink right into your mouth. A pump works on the exact same principle. But if the atmosphere is doing all this pushing for us, you have to wonder, that force can't be infinite, can it? And you would be right. There is a hard physical limit to just how high our atmosphere can push water. And here is that number. At sea level, in a perfect world with a perfect vacuum, the atmosphere can only push a column of water up to a maximum height of 33.9 feet. That's about 10.3 meters. That's it. That's the unbreakable ceiling, and it's dictated by physics, not by how powerful your pump is. Of course, in the real world, you never even get that high. If you're at a higher altitude, well, there's less atmospheric pressure to begin with. Long or narrow pipes, that creates friction that eats away at the pressure. Even warmer water makes it harder and reduces the effective lift. So what happens if you ignore these limits? What if you try to make a pump lift water too high? You run into a seriously destructive problem, a true pump killer, called cavitation. Cavitation is what happens when the pressure inside the pump drops so low that the water actually starts to boil. And I don't mean from heat. It's boiling because there's just not enough pressure holding it together as a liquid. These tiny vapor bubbles form, and then almost instantly they collapse with incredible violence, creating tiny little shock waves. The classic description really says it all. A cavitating pump sounds like you're pumping gravel or marbles. That awful rattling noise is literally the sound of millions of tiny implosions chipping away at the pump's middle parts from the inside out. It's incredibly destructive. The good news is, this is completely preventable. You just have to follow a few simple rules. You have to work with physics, not against it. Smart system design is all about preserving that precious atmospheric push. So you keep your suction lines short. You use wide pipes to minimize friction loss. And maybe the most important rule of all, you place the pump as close as you possibly can to the water source to reduce the vertical distance it has to lift. Which, brings us right back to the beginning. The next time you see a pump at work, remember what's really doing the heavy lifting. It isn't the machine itself, but the invisible weight of the air all around us. Pretty cool, right?